Hello everyone, Mr. Schultz here in Integrated Math 2. We're going to do 2-6, trapezoids and kites. Make sure your information is in the top left and right hand corners, and let's begin. So, the properties of a trapezoid is that it's a quadrilateral and only one pair of the sides are parallel. So we call these the bases, base 1 and base 2, and that they have their legs. Now, the other information that we need is what is the height? Because that's important when we need to figure out what is the area. Now, specifically, it's talking about, the properties of isosceles trapezoids. So, if a trapezoid is isosceles, then each pair of the base angles are congruent. That means, if the legs are congruent, then the angles are congruent. Now, also, the top angles are congruent as well, but not to the bottom angles. We don't know that. Let's continue. So if the trapezoid has one pair of congruent angles, then it's an isosceles trapezoid. That's like the converse. It's like, all right, if it's isosceles, then the angles are congruent. Well, if the angles are congruent, or if one of the pair of congruent base angles, then it's isosceles. And then we can infer, hey, look, the top is congruent as well. Let's go on. So, if a trapezoid has one pair of congruent base angles, then it is an isosceles triangle. Alright, slight correction. A trapezoid is an isosceles trapezoid if and only if the diagonals are congruent. So if AC is congruent to BD, then this is an isosceles trapezoid. Let's go on. Use the properties of isosceles triangles, example 1. So it's saying, hey, look, AB is 3x minus 2. And it's saying CD is 3x plus 9. Okay, well, that doesn't do anything. AD is 4x plus 5. Cool. And BC is 5x minus 6. Part A, prove x equals 11. Okay. Well, I know that 4x plus 5, I know that the sides are going to be equal to each other. So 4x plus 5 has to equal 5x minus 6. So I'm going to use the subtraction property of equality to isolate 4x by subtracting 4x on both sides. I get 5 is equal to x minus 6. Okay, what minus 6 equals 5? Now, I'd probably be like, it's 11, but I should probably use the addition property of equality and add 6 to both sides to get 11 is equal to x. Done. That's it. Let's go on. Part B. Find the perimeter. So hold up. All right, I jumped the gun a little bit. Part C is find the perimeter. Part B is find the measure of angle A if the measure of angle C is equal to 72 degrees. So I know this is equal to 72 degrees. So I know that this one's equal to 72 degrees, knowing that this is an isosceles trapezoid. So I know that the definition, or the interior sum angle theorem or whatever, that if it's a quadrilateral, it's equal to 360. So I know that if I add these two together, I get 144 degrees. So now I know that the measure of 140 degrees plus the measure of angle A plus the measure of angle B would equal 360. Now I know that these two angles are congruent. So I can say, I'm going to substitute the measure of angle A for B. So I get 2 times the measure of angle A plus 144, or I can subtract it now, and I figure out what does 2 times A equal. So I understand that's going to be 22. 216 degrees is equal to 2 times the measure of A. So if I divide by 2 on both sides, using the division property of equality, by dividing by 2, I get 108. Is equal to the measure of angle A. And that's it. Let's go on. Find the perimeter. I jumped the gun earlier. Okay, so it says find the perimeter of the trapezoid. Well, that just means add all the outsides. That's the perimeter. Add all the outsides. So if I was to add all these out, I'd get 3x plus 3x plus 4x plus 5x. That's 6x, 10x, 15x. So I get 15x. Then I have minus 2 minus 6, that's minus 8. 9 and 5, that's 14. 14 minus 8 is 6. So I have 15x plus 6. Well, remember x was 11. So now all I have to do is 15 times 11 plus 6. So I go like this. 15, whoop, that's not 15, that's 10. I go 15 times 11. 10 times 15 is 150. 1 times 15 is 15. I get 165 plus 6. So the perimeter is 171 units. Now, if it was in inches, it'd be inches. If it would be in feet, it'd be in feet. That's it. So let's go on. So isosceles trapezoids in the coordinate geometry. So here's the thing. Are the bases parallel? If they're not, then it's not a trapezoid. And finally, are the lengths congruent? If they are, using the distance formula or the informal slope, then we can determine, well, we should probably use the distance formula. Then we can figure out that this is a isosceles trapezoid. All right, let's go on. So, mid-segments of trapezoids. So, the mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the base. All right, so here's an example. If AB is equal to 5 and DC is equal to 10, what's EF? So this is like another one of those examples of, okay, take your money, take your friend's money, add them together and divide by 2, and that's what's in between. That's how much you would share together. So if we add 5 and 10, we get 15. Then if we divide by 2, we get 7.5. So EF would equal 7.5 because that's the sum or the add them together and then divide by 2. So EF is equal to 7.5 units. All right, let's go on to example 4. So example 4 is just pretty much that, except what if we give you the mid segment? What does the longer base have to be? So basically this is like, all right, we know that x plus 16.7 divided by 2 will equal 24. So now we just have to solve for x. This is now just an equation. We are figuring out what equation is this and solving for x. So what is the opposite of divide by 2? It's going to multiply by 2 on both sides. So when we do that, we get x plus 16.7 is equal to 48. Now we have to just subtract by 16.7 on both sides using the subtraction property of equality. And we get x is equal to 31.3. So LM, or x, is equal to 31.3 units. All right, let's go on to the next example. All right, so if we are going to figure out the mid-segment of each one of these, what we could do is we could figure out the midpoints in between the bases. So this base, we're going to figure out what is the midpoint between the bases, AD and BC. All right, so I would use the midpoint theorem and say, okay, x1 plus x2 divided by 2. And then we have y1 plus y2 divided by 2. And that's the formula. So let's do that for AB. So the midpoint of AB would equal 0 plus 18 divided by 2. And then we have 8 plus 8 divided by 2. I wonder what that's equal to. So 18 divided by 2 is 9. 16 divided by 2 is 8. So this would be at 9, 8 right here. Next up, the midpoint of CD will equal 1 plus 20 divided by 2 for the x values, and then the y values would be 4 plus 0 divided by 2. All right, well, 21 divided by 2 is going to be 10.5. And then 4 divided by 2 is 2. So this is at 10.5, right about there, and then 2, right there. So that would be my end points of the mid segment. All right, so that's trapezoids. Let's go on to kites. So now a kite. So a kite only has one pair of congruent angles. And since angle K does not equal angle M, we know that the opposite angles that are congruent would be N and L. So knowing this, I know that these two are equal. So let's call this X. I know that 2 times X plus 71 degrees plus 52 degrees would equal 360 degrees. Now, combining these, we would get 123 is equal to 360. Now, I could subtract by 123 on both sides as we're trying to isolate for x. And when we do that, we get 240, 237. Now we could divide by 2 on both sides. As we slowly isolate for the value for x, we get the measure of angle N is equal to 118.5 degrees. All right, let's go on. All right, so let's go on to the final example, example 7. Find the length in kites. Quadrilateral ABCD is a kite. Part A, find AD. All right, well, I know that AD is going to equal DC. So at the moment, I know that in kites, the diagonals are perpendicular to each other. So knowing this, I know that this is a right triangle, and we can use the Pythagorean theorem to figure this out. I know that it's going to be 12 squared plus 24 squared is equal to CD, which is the same as AD. So, give me a second. So I have 112 squared is 144. 24 squared is 576. So if I add those together, I get 2, carry the 1, 720 is equal to CD squared. So now I just have to find the square root of 720 to figure out what is CD equal to. So AD is going to equal 26.83. Now, we'll simplify the radical later, but if I just use my calculator, that's what I get. This is going to be simple plug and chug. All right, let's go to part 2, or part B. It says find the perimeter of kite ABCD. So once again, we understand that we have 26.83 is AD. So let's write this down, 26.83. I can literally times that by 2 and then add the top part times 2. So I know that these are equal. So I'm going to add 2 times whatever AB is equal to. So I know that I'm once again going to use the Pythagorean theorem. I'm going to do 12 squared plus 6 squared, squared, not degrees, to figure out what is the hypotenuse. So AB squared. And so I'll get 144 plus 36 is equal to AB squared. Adding those together, I get 180 is equal to AB squared. Now the opposite of squaring something would be the square root. So when I find the square root, I just plug it in my calculator and I determine the result. So using the calculator, I get 13.42 is equal to AB. So that means I'm going to multiply that by 2. And so if I use the calculator to do 2 times this plus 2 times that, I'll get the following. I get 80.49. All right, guys. That's it for Chapter 2. That's it for this semester. I'll catch you guys later. See you next semester. Have a good night. Bye.